Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, chapter 1-2, travel expenses. What are travel expenses? Well, if I want to go on vacation, everything that I spent on that is a travel expense, be it plane ticket, train ticket, taxi, dinner, that kind of thing, hotel. Travel expense can be personal or it can be business. So if you work for a business and they send you somewhere and you fly and stay in a hotel and eat, they reimburse you. So it's important that you pay attention to what you did and how much you paid for everything so that you get reimbursed. So you're not paying for this stuff. So travel expenses, here we go. So there are a few vocabulary words in this chapter section: cumulative frequency, relative cumulative frequency, percentile, percentile rank, and one I didn't mention, and that is when we're talking about spreadsheets, and every square in a spreadsheet is called a cell. All right, so how many of the trips listed in the summer travel table frequency distribution table on page 14 were less than 1,000 miles? So the table that I got from page 14, it was just this right here. Okay, a cumulative frequency. Let's explain what frequency is first. Okay, frequency in this situation means how frequent something occurs, how many times something occurs. So what was the frequency of long distance travel that was 50 miles or greater, but less than 250? And it was 512,460,000. That is the frequency, number of long distance summer trips. How many times? That's the frequency. So this is a table with frequencies in it, and they're broken up into different groups, and therefore that's being distributed. So these were put in this group, these were put in this group, and so on. So that is a frequency distribution table. And so now we're going to answer this question using a cumulative frequency. So what a cumulative frequency is you have a new column and you start with the first one. So this just gets carried over to here. All right, and that doesn't change. But then we add, and then we go down here and we add that to it and put our result here. So take this plus this, that's that. Take this plus 32 is 617. 617 plus 32 is 650. Okay, so the cumulative frequency column is what we're going to use to answer this question. So how many of the trips listed in the summer vacation table on page 14 were less than 1,000 miles? Well, this is greater than 1,000 miles, so I'm not going to use that data right there. Okay, 500 to 1,000, but less than is going to be used. And this is less than 500, so it's obviously less than 1,000. And anything less than 250 is obviously less than 1,000. So what I want to do is use the cumulative frequency all the way up to, but not including this 1,000. And therefore, the answer to this problem is right here. Okay, so after traveling, or how many travelers traveled less than 1,000 miles? And it is 617,580,000. Okay, so now pause the video, see if you can answer this check your understanding question, come back and see how you did. Okay, so assuming that you've done that, this one says how many trips less than 500 miles in length were taken. So let me erase these. And so if we're going to be less than 500, well, more than 1,000 is not going to be part of the solution. This is less than 1,000, but it's 500 or greater. So I'm not going to use that because I want less than 500. And so here is my less than 500. It begins right here. And obviously 50 to 250 is also less than 500. So to answer this question, the answer to this question is the cumulative frequency that ends before we get to 500. So the answer to the check for your understanding, the answer is 584,730,000. Okay, so that's a cumulative frequency table. Okay, page 2 brings us to example 2, and it says, the flight travel website reported the following airfare booking expenses for the week of July 4th. What proportion of the tickets sold? Okay, so we have proportion. What proportion? What proportion of the tickets sold had a cost greater than or equal to $400 and less than or equal to $499.99? All right. So I brought the definition in for relative frequency. That's the definition for this problem. And a relative frequency is the ratio. A ratio is a comparison of two things, A divided by B, of the frequency of a particular interval to the total number of pieces of data collected. So each of these numbers here would be our numerator, A. This is an A, and this is an A, and this is an A. And B would be the sum of all of these. So the first thing we're going to do to answer this question is we're going to tally up totals. We're going to do a cumulative frequency. So as you can see, we have the first column doesn't change except we added one row with the total in it. And then so the next column didn't change, number of bookings, this is all the same, 70 all the way down to 22, but all we did here was add those all up and the total is 1,434. So that right there is going to be our denominator when calculating this, okay? So in looking at this definition, the ratio of the frequency of a partial interval to the total. So we're going to compare pieces of this to the total. So here is the formula. There's two different formulas. One's similar to the other. Let me just get this out of the way now. Relative frequency expressed as a decimal, RF is just short for the relative frequency, and that equals F divided by N. I don't really like the way they depict this in the book because it looks like some letter R or variable R times some F, and these two F's are the same, but that's not the case. That RF over here just means relative frequency, and this is the frequency divided by N being our total. So if I wanted to know, for example, how many tickets sold between 100 and 199.99, what proportion? It'd be 70 out of the total. Okay. Relative frequency expressed as a percent. Now, hopefully you all realize that if you just have a number, that if you multiply it by 100, that moves the decimal 2 places to the right. And that's how you express a percent as a value. Okay. So the next thing we're going to do is answer the question. What proportion of tickets sold had a cost greater than or equal to 400? Okay, so let me just draw a circle around that. So greater than or equal to 400 and less than or equal to 499. So that is this amount here. So we're going to take 282 and we're going to divide it by the total. Okay, so what proportion of tickets sold had a cost greater than or equal to 400 and less than or equal to 499? So it's 400 to 499 is 282. So you would answer this by saying 282. So I'd say RF. And you should always write the formula. So let me just do that. So in math, I always have these 4 steps. How do you solve a problem? Step 1, write the formula. RF equals F divided by N. Step 2, substitute in the givens. RF equals 282 divided by 1434. And finally, the third step is simplify and solve. So if I take 282 and divide it by 1434, 282 divided by 1434, I get 19.66 or 19.7%. Okay. So that's a percent. Relative frequency expressed as a percent. So if I look at my calculator, notice what I did. It is 0.1967. So let me just do that before I go to percent. Okay, so let me just put that is 0.1967. Okay, so the relative frequency is 0.1967. That is this formula here. Now to get the relative frequency to be a percent, you just multiply it by 100. So RF equals, multiplying by 100 moves the decimal 2 places to the right, and that'll give me 19.7 rounding to the 10th position percent. Okay, so there is the answer to example 2. Okay, so what I could do is do that for every column also. 70, so I could take this and I could say, okay, well, what is when F is 70? And let me do something first. Let me show you a trick in the calculator so you have to type so much. If I store a value, we're going to use the same total. So I can store that as a variable. And so if I say, well, let 1,434 get stored as my variable X. So you do 1434, there's this button here that says STOX. And if you hit enter now the calculator knows that you stored a value for X. So now all I have to do is say 70 divided by X instead of typing 1434 every time. And now you have 0.048, which is 0.049 rounded to the 1000th position, 3 decimal places. Okay, so you always look out 4th place. If that is 5 or greater, this rounds up, making that a 9. So I just keep doing that. 120 divided by X, enter, and I got 0.80836. The 6 makes this 3 a 4, so it's 0.084. And that process is just going to continue for the entire table, and there you have it. So now it says, check your understanding. What percent of the total number of bookings fall within the range of $700 to $899? So pause the video, see if you can do this, and then come back. Okay, so 700 to 899.99 is these two. Okay. All right, so that is going to be what I would do, because these are rounded. If you just add these, you're adding 2 numbers that are rounded, and your approximation is off by even more. What I would do to be more accurate is put this in my calculator. So I'd do this. I would say 100, actually I could put it in parentheses, 136 plus 80. So whatever that gives it me, and then divide that sum by my 1,434, and that will give me 0.1506, which rounds to 0.151. So that would be, I would say RF, showing my work, I would say RF equals F over N. Write the formula, substitute, and F is 136 plus 80 divided by 1434. Okay, and then that would simplify to 612 over 1434, and then that would equal what we got, 0.1506. And I shouldn't put equals here because I am rounding, so now it is an approximation. You can write equals all the way up until you're converting a fraction to a decimal. That's not going to terminate. Okay, so there's an approximation. And so then I turn it to a percent, and RF is, and there I go again with my equals, approximately 15.1%. Okay. Okay, example 3 is going to address spreadsheets. So hopefully you have a little bit of experience with spreadsheets. If not, that's okay too, but they're really useful if you're doing any calculations. It makes life so much easier. So number 3 says, write the spreadsheet formula that would find the sum of the relative frequencies and enter that calculated amount in cell C12. Okay, so I created a spreadsheet and I entered, oops, not that one. Let me close that. I did it in Google Drive. Where is it? Oh, right here. Okay, so round trip air ticket cost came from the book. That was column A from page 14. Number of bookings is the next one. I haven't entered those yet, so I'll just do that now. These are all called cells. They call them cells in a spreadsheet. So this was the table from the last problem because it has the total row. So number of bookings was, so I click in this cell. Now, if you want to format cells, you can click and drag a group of cells. And then if I come over here and I change it to center the text, then when I click in here, the numbers were 70, 120, and I'll just keep adding these. Okay, so there is the numbers. Let me just change the text here. And I want it all Century School Book. I like that font, it looks good. And let's make it all font 11. Okay, so there are the values that were given to us. Now, in order to do a summation here, all I have to do is click here. And I come over to this sigma notation. All right, so we talked about that in the last video. And then if you click on that, it gives you a bunch of commands you can do. We're just simply going to do the sum. And it automatically chose, actually didn't choose anything. So I'm going to click here and drag down to here. So then it filled it in, and there is the answer to our question. So it is the sum of B2 to B11. I'm just going to hit enter now. And there's that 1,434. Now I'm going to go back to here, and my answer is going to be, it is going to equal the sum of B2 to B11, okay? So did I answer that? The sum of the relative frequencies. Okay, that is not the sum of the relative frequencies. That was the sum of the frequencies. Okay, so let me just leave that there. This is the sum of frequencies, not the relative frequencies. Now we're going to do the sum of the relative frequencies. So now I'm going to go back to my spreadsheet. And what is relative frequency? Well, we can have this calculated too. If I click on this cell and hit the equal sign, and I want it to equal my F divided by my total, and hit enter. And then I want to round it to that and center it. So if you remember, that answer was 0.049. Now what's really nice about a spreadsheet is once you do one formula, you click here, and if you put a $sign in front of the cell name B and a $sign in front of the 12, the B12 is our total right here. We're going to take this divided by this every time. And you put a $sign in front of the column name and the row name, and that locks in the value. It will not allow that to change. But when I drag this down, B2 will become B3, but B12 will stay the same because of those $signs. Okay. So now I'm going to hit enter and it won't change the value of this. And now look what it says here. Autofill, suggest autofill, sure. And boom, we're done. And notice the total. These better add up to 100% or else we aren't taking into consideration every single booking. And you can't have more than 100%, it's not possible, okay? So there is the table all the way out to the total. So cell C2 is going to be B2 divided by B12. Okay, so the question now is, in the problem, the sum of the relative frequencies, and enter the calculated amount in C12. So if I come down here, C12 is right here. There's our formula. So you're taking, actually, another way we could do this is we could just delete this one. And we could take the sum of these, and we'll still get 1. So my formula could be sum of C2, whatever was here, plus all the way down to C11. All right, so now if I go back to here, I'm going to say the sum of my relative frequency is the sum of C2 through C11. And what that means is C2 plus C3 plus ... plus C11. All the C column cells from 2 to 11. Okay, now it's your turn. Check your understanding. Pause the video, see if you can do this. Come back and see how you did. Okay, so assuming you did that, it says, suppose that you wanted to add a 4th column that expressed the relative frequency as a percent. What formula would you enter into cell D2? So if I don't remember, I can go back here and I can say, okay, what do? I take my relative frequency and multiply it by 100. Okay, so if I go back to my spreadsheet and I have a new column, I can just drag this over and it'll repeat. And instead of rounding to the nearest 1,000, I will say in percent. So there's my new column. And so what I can do is say, I can say equals this times 100 and autofill. And I want to round to 1 decimal place. Okay, so then if I do this, decreasing the number of decimal places until I get to 1. And then I want to center my data. I just go up to here and hit center. So there it is, 4.9%, 8.4%, 21.6%, and so on. And I can just click on these and click the percent now. Okay, so what that did was multiplied it by 100. So you don't want to do that. So I'm glad I did that. So the one way to do it is just multiply this column by 100 and you'll get the percent, or you can just do this. Let's get rid of this. All I want to do is take this column and copy it over. Control C, Control V. Why is that not copying? Control copy, Control paste. Okay, one moment. Okay, so whenever you want to see what's going on, why did this occur, you can always look at your formula in one cell. And this is taking C2 and dividing it by B12. Okay, so it's taking a percent of a percent really. So what I want to do is change this to B, and that will change that back to 0.49 and then drag the formula down like so. And then once I do that, now they're equal. Okay, then once I do that, I can just hit the percent. Okay, so that's another way we can do it. All righty. Okay, example 4. It says to extend the relative frequency table on page 16 to determine the percent of the fly travel bookings that are below $600. So in order to do that, to find a percent, we need to do a cumulative frequency. And the next definition is relative cumulative frequency, and that is the ratio of the cumulative frequency of a particular interval to the total number of pieces of data collected. Okay, and then just ignore that. All right, so think about that. The ratio of the cumulative frequency. So let me go back to my last table. So we had a relative frequency, but now we want to accumulate those and make a cumulative frequency of bookings and so forth. Okay, so here's what we're going to do. So the definition or the formula for a relative cumulative frequency is RCF, for relative cumulative frequency, and that equals the cumulative frequency divided by the total. And then just multiply it by 100 for percent. Okay, so relative cumulative frequency is the cumulative frequency divided by the total. So we need to do a cumulative frequency. So let me get the definition out of the way here. So we want to examine the entries in the extended table. So what did they extend the table to? Okay, they extended it to a cumulative frequency. So this is our frequency F. So this was F originally. So now this is going to be CF, cumulative frequency. So I'm going to combine these and start adding them up. So if I go back to my spreadsheet now, all I'm going to do is call this cumulative frequency. So I'd like to just copy over the previous one to get the cell stuff, the font and everything. Okay, so cumulative frequency, and this is going to equal this, okay? But then I don't want that. I want this center too, by the way. So I'm going to choose all these cells and I'm going to center. Now I want this to equal this plus the next one. And now I'm going to drag this formula down, and it's going to take 190 plus 310 and so on. And it's just going to finish it for me. Okay, so there it is. The cumulative frequency gets up to our total. Okay, this should equal this. Okay, so if I go, now what do I want to do? Well, I did a relative frequency of this column. Now I want to do a relative relative cumulative frequency. So I'm going to copy this over here and paste it. Control V. Okay, but I'm going to add the word cumulative. Okay, relative cumulative frequency rounded to the nearest thousandth. So what was this formula? This was B2 divided by our total. So this is going to equal E2 divided by, and remember our total doesn't want to change, so I'm going to put a $sign E, $sign 12, and hit enter, and then autofill and center. Okay, so I always like to include the total. That's my way of checking. So when I got to this, I need that to equal 1, obviously. All right, so then I'm going to change this to, let's go 2 decimal places. So let's shorten that down to 2 decimal places. Okay. I guess, there you go. Okay, so there it is. So if I go back to this page, that is actually what they had done. So let's check my numbers. 70 all the way to 1434. 70 ended up at 1434, not counting this total here. So oops, I need that. Okay. And then when I go back to here, I got 0.049, 0.984. I'm just checking my values. Okay, that's not correct. 024, and I only got out to 1 here. So what's going on there? So let me go back. So this should equal that. This should equal this. I need to start there. That's where I went wrong. Okay. Then I'm going to keep adding. So I want, let's see, this. So I want this column or this cell to equal this cell plus the next one, 0.132. Okay, and then I want to drag that down. Let me delete this one. So that should always total 1 right here. All right, so what's happening there? I'm accumulating all these values. 0.049 plus 0.084 is 0.132. 0.132 plus 0.216 is 0.349. And I keep accumulating the relative cumulative frequency until I get down to 1. I don't need this here now. Okay, so there is our table with a relative cumulative frequency. So it's this column accumulating. Okay, so now it's your turn. It says, what does 0.545 in relative cumulative frequency column represent? Okay, pause the video, see if you can answer this question, and then come back. Okay, so the 0.545 is right here. So it is remember it's cumulative. So what they're saying is round trip airline tickets that cost between $100 and $499.99 represents 54.5% of the airline tickets that we are talking about in this set of data. Okay, so 54.5% are under $500. Okay. Extend your understanding. Round to the nearest whole number. What percent bookings fell between 700 and 999? So pause the video, see if you can answer this, and then come back. Okay, so here we go. So between 700, so that would be more than 700, but less than 999. So I want this data here. Okay, so all of this data, covering up this number. So in order to pick values that are within in the middle, not including the starting or ending point, okay, I can't say that 98.4% of the data is in these three. So what I have to do is I have to subtract 76.7% of the data is right here. So I take 0.984, which is all of this data, and subtract what's not in it, which is 0.767. And when I do that, I get 712. So 21.7% of the airline tickets were between $700 and $999.99. Okay, so since we use this spreadsheet, I do need you to know where those values came from. The spreadsheet does it for you, and sometimes you lose track of what those mean. Okay, so relative cumulative frequency expressed as a decimal is the cumulative frequency divided by the total. And then to get a percent, you multiply it by 100. So if I go back to my spreadsheet, cumulative frequency divided by the total is the relative cumulative frequency. So this number is the cumulative frequency divided by the total. So if I click on it, it equals C2. C2 is right here, which is F divided by the total. But if I click here, this is F2, which is this number, okay, the cumulative frequency. So what it's doing is it's just taking the cumulative frequency and dividing it by the total. So I could change my formula here if I wanted to. I could come here and I could hit delete, and then I could say equals cumulative frequency divided by the total. And it would be the same value, 0.132. Okay, percentiles. Recall the median of a data set. The median is the middle score. If the number count was odd, and the average of the two middle scores, if the number count is even. That was in lesson 1.1. It divides the data into two equal parts. Since the median is the middle, 50% of the data falls above it and 50% falls below it. Rather than dividing the data into two parts, suppose you divided the data into 100 equal parts. Each part is known as a percentile. So there's the next definition. The word percentile just means what portion of that percent. Unfortunately, there isn't complete agreement on the definition of percentile. Rather than offering and using all of the possibilities, we will stick to the following. A percentile is a statistical measure used to compare data. It indicates what percent of the frequency total appears at or below a particular number. Okay, so there's the key here. What percent of the frequency total appears at or below the number? A percentile rank is the percentage of numbers that fall at or below a given number in the list. The median is often referred to as the 50th percentile. Percentile ranks are usually written to the nearest whole percent. Here you can learn how to calculate the percentiles. So if you've taken the SAT, they give you a percentile rank. Were you in the 80th percentile? That means that you scored better than 80% of the population. So that's percentile. So you've heard it before, so let's delve into this a little deeper for the next example. Okay, so example 5 says, most cities have some form of taxi cab services for short distance trips. Usually the cab fares are either a flat fee for a specified distance or a metered fee. The metered cabs often start with an initial fee and then charge a fixed rate per fraction of a mile driven. In many cities, wait time, the number of stops often affect the fare as well. You're sitting at a light, still ticking. The website taxifarefinder.com offers a ranking of cities by the cost of a hypothetical taxi trip of a given duration and distance. Of the top 80 most expensive cities, these are the initial cab fees in ranked order. So they go from $1.95 all the way up to $10. What is the percentile rank of a $3 initial cab fee? So notice there's a lot of $3 in here. Okay, so I will say percentile rank of $3 equals, now remember what we have to do. We want to find the values that are at or below the value we're looking at. So let's take a look at how many are below. So $3 started here. So all of these over here are below. And there's 1, 2, 3, 4, 5, 6, 7, 8 times 3. There are 24 values below $3. I now want to look at how many are at $3. Okay, so that's all of these because here's 310. So we have 1, 2, 3, 4 columns of 8, which is 32. So my answer to this problem is the at or below and out of the total. So that would be 56 out of 80. Okay. And then I want to multiply that by 100 to get a percent. Okay. So if I go to my calculator, 56 divided by 80, what is that? 0.7. Yeah. Multiply that by 100, moves the decimal 2 places to the right, and that would give me a 70. Okay. So the percentile rank of a $3 initial cab fee is 70%. That means that 70% of the initial fares listed are at or below $3. Okay, simple enough. So let's move on to check your understanding. And it says, determine the percentile rank for an initial fee of $285. Pause the video, see if you can come up with that, and we'll check it. Okay, so again, we're going to just simply determine the values that are less than 285, which are these over here. 285 starts there. And remember, there were 8 plus 2 is 10. And then we want to have all the 285s, which are here. So there's 8 and 6 more is 14. So I would say the percentile rank of 285 equals at or below our total. And our total was 80. Okay, so that's going to equal 24 over 80. And we want the percentile rank, so we're going to multiply by 100. So that is going to equal, okay, well, 24 divided by 8 is 3. So 24 divided by 80 is 0.3. Okay, and 0.3 times 100 moves the decimal 2 places to the right, and that'd be 30%. So 30% of the data is at or below $2.85.